Hey everyone, we are working in the textbook today. I am on page M2-28, and the title of the section is called Factoring Special Binomials. So this is just a fancy way of saying we're going to be factoring things that only have two terms, factoring expressions with two terms or two terms only, using these very nifty, very helpful formulas. So for question number one, use the difference of squares to factor each binomial over the set of real numbers. So all that means is we're not having any imaginary components to these problems. So for number 1a, we're doing x squared minus 64. And again, we're going to use this formula that they gave us up here, the difference of squares formula. So whenever we have a perfect square, and then we subtract another perfect square, the factors are equal to this. So what I'm going to do here is rewrite it as, I'm going to rewrite x squared minus 64 as x squared minus, and what I'm doing is trying to make this look like this. So you really need to just be able to look at numbers and be able to pick out right away, hey, I know that 64 is a perfect square. I know that 64 is the exact same thing as 8 squared. So I haven't changed the value at all. I just simplified it a little bit so that way I can use this formula. I know that 8 squared is equal to 64. So if I apply the formula now, this formula here, it looks like I just take the base of each one of these terms, add them together, and multiply it by each term, and then I just subtract. So this is going to go x minus, or plus, I guess I'll use the formula that they use up here, x plus 8 times x minus 8. Okay, and that's it. Little box around it that is factored. So again, just nifty ways of doing these types of problems. So for part B, we are going to do, this one is to the power 4, but that's okay. I can still rewrite it. And then we have 16, but we can rewrite that as well. So x to the power of 4 is the exact same thing as x squared to the power of 2. X squared to the power of 2. And then minus, so for 16, again, it's what can I square to get to 16? So that would be 4. So we have everything we need now to apply this difference of squares formula. We've got a term being squared, and then we're subtracting another term being squared. So this will simplify into x squared plus 4 times x squared minus 4. All right, fantastic. This next one, same idea. One's a perfect square, and we can simplify this pretty easily as well. So let's rewrite this as x to the power of 4 and then squared. So x to the power of 4 squared is x to the power of 8. And then we'll do minus. And this is easy because, well, hey, 1 squared is 1. So there we go. We've got our two terms, our two perfect squares. We're subtracting those values or those terms. And so now we can apply that formula. So we'll have x to the power of 4 plus 1 times x to the power of 4 minus 1. And you can verify that we're going to get back to where we were because x to the power of 4 times x to the power of 4. Remember, when you're multiplying variables with exponents, you really just add the exponent. So x to the power of 4 times x to the power of 4 is x to the power of 8. Just add the exponents. 1 times negative 1 is going to give us negative 1. And since these are inversed, add and subtract will cancel out that middle term. leaving us with x to the power of 8 minus 1. All right, moving on to part D. I'll practice this one more time. So even if we have two variables, that is totally fine. We can still factor this. First, though, we're going to rewrite it in terms of perfect squares. So x squared squared is x to the power of 4. Y squared squared is y to the power of 4. Now that I'm subtracting two perfect squares, I can apply that formula. So this will be x squared plus y squared times x squared minus y squared. So again, we're just pulling out the bases of these squares, okay? And that's it, perfectly factored. Once again, you can verify that it works. X squared times x squared is x to the power of 4. Y squared times a negative y squared is negative y to the power of 4. Okay, so for this next part, this guy tried to find some factors here, but it's not a perfect square. It's actually a cube. So there's a lot more involved here, and this is not going to work for you. So it's a little bit of a process. Essentially, what we're going to do is try to factor things that look like this, but instead of having x squared, it's going to say x cubed. So we'll have another formula. It's just a little bit harder, and we'll look at long division during the next class period. So we're going to skip question 2 for now. Yeah. I am lost on which pages I'm on. All right, perfect. We are on page M2-29 now. Okay. So again, this is kind of the basis of what we're doing. So let's, once again, we'll do long division here in just a couple of different class periods. We'll move on to question 3. So I'm on page M2-29, question 3. It says use the properties of equality to determine 1, 0. Then factor each polynomial function over the set of real numbers. So what we're doing is pulling out one real solution out of this function using the properties of equality. Well, that just means we're going to set this equal to 0. So 0 equals x cubed minus 27. Okay. Now, if we're using properties of equality, we would add 27 to each side of our equation. And we'll be left with 27 equals x cubed. Now, when you need to get rid of an exponent, the opposite is taking the root of that exponent. So to cancel this out, you know how the opposite of subtracting was addition? To cancel out this cubed exponent, we're going to take the cubed root. And it's algebra, so I need to take the cubed root of this side of the equation. So on a calculator, this will be well, let's hit math. If you just hit the math button, and then we can scroll down to option number 4. So that is what this means, the cubed root of this value. So I'm doing the cubed root of 27. There we go, that should work. And we get 3. So we know for a fact that x is equal to 3. If we know that x is equal to 3, we have a factor here. If x is equal to 3, one of the factors is x minus 3. All right, fantastic. This one, pretty much the same idea. 0 equals x cubed plus 27. Okay. To solve, we'll have to do the opposite operations. So we're going to have negative 27 equals x cubed. And then once again, the opposite of cubing something is taking the cubed root. So when you take a cubed root, you can actually have a negative sign in the radical. Remember, for square roots, that's impossible. You make something imaginary. But cubed roots, you can actually do that. So I'm just going to change this to negative 27. Okay, I'll hit enter. Whoops, negative 27. I'll hit enter. And we get negative 3 as our result. So what that means is negative 3 times negative 3 times negative 3 gives us negative 27. All right. So going back here, negative 3 is equal to x. Since x is equal to negative 3, we have a factor here, which is x plus 3. So what gets difficult is we have this factor, but we need to figure out what can we multiply by over here to get back to this original equation. What can we multiply by to get back to x cubed plus 27? So a couple things that we're going to have is we'll have to multiply by x squared because x times x is x cubed. And we know on the end here, we'll have to multiply by 9 because 3 times 9 is 27. Now this middle term is essentially these two terms put together and the opposite sign. So this middle term, I'll explain this as we do long division, but for now, it is negative 3x. Okay, and then you could factor this more if you really wanted to, but that's okay. We're just going to leave it right there. So there's a formula to follow to arrive at this destination without having to solve, without having to really think about what's going to be in the second group of parentheses. So just determine the formula for the sum of cubes. So this is the sum of cubes formula. This is a very important thing. It'll help you factor things that look like this. So the sum of cubes formula is if we have two perfect cubes, a cubed plus b cubed, these will factor into a plus b times a squared plus, not plus, whoops, it's actually a minus sign, minus ab plus b squared. And you can see kind of how I got that over here, I think. For example, this a, the first term here being x, I squared it. The very last term, really thinking about what's the base of 27, remember that was 3. I squared it, and that's how I got 9. Anyways, we'll practice using this formula in the next problem, so I'm not going to go too far into it. But that is the sum of cubes. Now, we also need the difference of cubes formula. The difference of cubes works pretty much the same way. When we have something cubed minus something cubed, the formula just changes signs in a couple areas. So instead of having a plus b, we're going to have a minus b, and then we're going to be multiplying by a squared plus ab plus b squared. Okay, so use the sum or difference of cubes to factor each binomial over the set of real numbers. So what we're going to be doing is much the same of what happened here. Remember, we rewrote these as perfect squares. But instead of perfect squares, we're going to do perfect cubes. So how we know that 4 squared is 16, let's apply that kind of same logic over here to this problem, question number 5. So first off, we know we're going to use the sum of cubes formula because we have the plus sign there. Now let's think about how to rewrite it. So x cubed plus 125 is equal to the exact same thing as x cubed plus, all right, so this value, the value for b in this formula, it is what cubed gives me 125. So how you can figure that out is just go to a calculator and do the cubed root of 125. And we get 5. So 5 times 5 times 5 gives you 125. So I'm going to rewrite 125 as 5 to the power of 3. Okay. Now that we have it set up like this, we can use our formula. So hey, x cubed plus 5 cubed is going to factor to x plus 5 times, so a is just talking about your first term, the base of the first term. So I've got x. What am I doing to x? I'm squaring it. And then I've got minus a times b. So I need to multiply these two things. I need to multiply x by 5, which gives me 5x. And then plus, I'm taking the second term, and then I'm squaring it. So I need to do 5 squared. 5 squared is 25. And that is it, 100% factored at that point. Okay, cool. Move on to part B. So it looks a little bit more confusing, but it's really not too bad. Remember, we need to find cube roots of these things. So we're going to rewrite 8x cubed as, I did this for a reason, the cube root of 8 is 2. So just to verify, 2 to the power of 3 gives you 8. So I'm going to rewrite 8 as 2 to the power of 3. All right. I'm going to wrap this one in parentheses to make it more clear. 2 cubed to give me 8, x cubed to give me x cubed. Now 1 is easy because, well, 1 times 1 times 1 is 1. So 1 cubed is the exact same thing as 1. So this is your value of a. This is your value of b. All you need to do is plug them into whichever formula applies. So hey, since we have a subtraction sign between our two cubes, we're going to use the difference of cubes formula. So this will be 2x minus 1 times, all right, so I take my first term and then square it. So 2x squared is 4x. And then I'm going to do plus. Now I need to multiply these two things. So 2x times 1 is 2x. Forgot to put a square there. And then the last step here is plus this value squared. So 1 squared is also 1. And there we go, all done. Hey, one way to check your work at this point is to try to multiply and make sure you can get your first term and last term. So 2x times 4x squared, all 2 times 4 is 8. X times x squared is x cubed. And then -1 times +1 is -1. So perfect. We're looking pretty good at that point. Move on to this next one. So we're starting off with x to the power of 6. So even though it says x to the power of 6, we need to rewrite it as a perfect cube. So this will turn into x to the power of 2, and then to the power of 3. x squared to the power of 3 is x to the power 6. So if you take an exponent of an exponent, you're multiplying. 2 times 3 to give us 6. Now the 8, we already broke it down over here. We know that 8 can be rewritten as 2 to the power of 3. Once you have this situation, we can apply either the sum or difference of cubes formula. So in this case, it is going to be x squared minus 2 times doing the difference. So that would be x to the power of 4 plus 2x squared, because I'm multiplying, and then plus 4. All right, so you can try part D on your own. Maybe I'll cover that one during the live Zoom session during class. But otherwise, thanks for watching. We'll practice this more, and I'll see you soon. Bye-bye.